In less than 12 days, something will happen that has never happened before in the history of human space observation. An object designated 3I/Atlas, an interstellar visitor from beyond our solar system, will vanish behind the Sun at perihelion, and during those critical weeks we will lose every single ability to track it. The timing is almost surgical in its precision. The blackout period coincides exactly with the moment when solar heating should force this mysterious traveler to reveal its true nature, yet we will be completely blind. Every telescope on Earth will be pointed uselessly at nearly 1,000,000 miles of incandescent plasma, unable to see what happens on the other side. December will tell us if the same object emerges, or if something else comes out instead. But what we discovered before it disappeared has left the global scientific community deeply unsettled. The James Webb Space Telescope detected an 8:1 carbon dioxide to water ratio, a measurement sitting 6 standard deviations above every comet ever recorded in human history. Think about that for a moment. 6 sigma. In statistical terms, that means the odds of this happening by random chance are less than 1 in a billion. The Keck Observatory in Hawaii mapped nickel emissions in ratios that look disturbingly similar to industrial alloys, not primordial ice from the dawn of another star system. Spacecraft orbiting Mars photographed it showing sunward-biased outgassing that defies every fundamental principle of comet physics we have established over centuries of observation. The trajectory probability, threading through space at 5 degrees from the ecliptic with close approaches to 3 different planets, calculates to odds of 1 in 20,000. And researchers have published calculations showing that if anything wanted to break and enter a bound solar orbit around our Sun right now, hiding behind our star would be the mathematically optimal moment to execute such a maneuver using what's called a solar Oberth burn. The accumulated improbabilities have reached a threshold where dismissing them requires more faith than seriously considering what they might mean. Before we go any further, I need you to do something for me. If this mystery intrigues you, if you want to follow this story to its conclusion, hit that subscribe button right now and turn on notifications. This channel will be covering every development as it unfolds, and you do not want to miss what happens when 3I/Atlas reemerges in December. Drop a comment telling me what you think is really going on with this object. Is it a comet with bizarre chemistry, or could it be something else entirely? And make sure you smash that like button because understanding what we're dealing with here might be one of the most important scientific investigations of our lifetime. The algorithm needs to know this matters. Let me set the scene properly so you understand exactly how extraordinary this situation has become. For months now, astronomers around the world have been watching 3I/Atlas with an intensity rarely reserved for objects passing through our solar system. The James Webb Space Telescope, humanity's most powerful eye on the cosmos, turned its billion-dollar instruments toward this visitor. The Hubble captured its teardrop-shaped coma in exquisite detail that revealed structures nobody expected. Ground-based observatories stretching from the mountains of Chile to the volcanic peaks of Hawaii tracked its every movement across the star field. Spacecraft currently orbiting Mars prepared their cameras and spectrometers to photograph it as it sailed past the red planet. This was not just scientific curiosity in action. This was something approaching obsession, and there were very good reasons for that intensity. Every measurement captured, every spectrum analyzed, every image processed revealed something that simply did not fit the established playbook for comets. Carbon dioxide outgassing when the object should have been dormant and frozen. Chemical signatures that resembled engineered materials more than ancient ice. A trajectory that threaded the gravitational needle between multiple planets with a precision that made professional statisticians deeply uncomfortable. And now, just as this visitor reaches the moment of maximum solar heating, just as its ices should sublimate most violently, just as we should be learning the most crucial information about its true composition and nature, it disappears from view entirely. The geometry is simple but profoundly frustrating for observers. 3I/Atlas approached the Sun from one direction while Earth sits on the complete opposite side of our star. For several weeks, the Sun itself blocks our view like a cosmic curtain. No telescope on Earth, no satellite in Earth orbit, can see through nearly 1 million miles of incandescent plasma. We exist in what astronomers call superior conjunction, and the timing could not possibly be worse. Or perhaps, depending on your perspective, the timing is precisely right. October 29th marked perihelion, the moment when 3I/Atlas closed to within 1.36 astronomical units of the Sun. To put that distance in perspective, it passed closer to our star than Mars ever gets during its orbit, sliding through a region of space where temperatures soar to extremes and solar radiation intensifies to punishing levels. This is the crucible, the testing ground. This is where comets made of primordial ice and rock either prove their nature through predictable behavior or reveal something else entirely, something that challenges our understanding. When a comet composed of ancient ice and rock encounters this magnitude of heat, highly predictable phenomena occur. Water locked in frozen crystal structures sublimates directly into steam without passing through liquid phase. Frozen carbon dioxide transforms directly into expanding gas clouds. Dust particles lift from the surface, carried outward by the pressure of expanding vapor. The coma, that fuzzy envelope surrounding the hidden nucleus, grows visibly brighter and expands to enormous size. The tail stretches for millions of miles behind the comet, pushed relentlessly by solar wind and the pressure of radiation itself. We have witnessed this cosmic dance countless times throughout human history. We understand the choreography, the physics, the mathematical relationships that govern these transformations. But 3I/Atlas has never, not once, followed the expected script. And now, at the most critical moment of its entire passage through our solar system, we cannot watch the performance. The blackout is not absolutely total, of course. There are other observation platforms scattered throughout the inner solar system, though their capabilities are severely limited. The spacecraft currently orbiting Mars managed to catch brief glimpses as 3I/Atlas passed within 0.19 astronomical units of the red planet on October 3rd. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter both rotated their instruments toward the visitor, capturing images that showed a faint smudge against the background tapestry of stars. These were not close-up portraits revealing surface details. From Mars's perspective, 3I/Atlas remained nearly 19 million miles distant, a dim object requiring extended exposures and careful image processing just to confirm its presence. But they saw it. They verified it was still there, still moving through space, still actively outgassing material. Whether anything changed during that narrow observation window, whether the comet brightened or dimmed or exhibited any unexpected behavior, remains unclear. The data exists somewhere in the digital archives of mission control centers, but it has not been publicly released yet. Then came the solar blackout period. For Earth-based observers, 3I/Atlas effectively ceased to exist as an observable object. Radio telescopes cannot help us penetrate the Sun's interference. Radar cannot reach across interplanetary distances to detect something hidden behind our star. Infrared observations become useless when your target hides behind an infrared furnace outputting unimaginable thermal energy. We sit in the dark, and we will remain in darkness until December arrives. That is when 3I/Atlas is scheduled to reemerge on the opposite side of the Sun, continuing its hyperbolic trajectory outward from the inner solar system and presumably back toward interstellar space. December, a full month and more of profound uncertainty, a full month of wondering what might be happening in that hidden space behind our star, wondering if the laws of physics are the only forces at work. Now let me be completely transparent about something important. Superior conjunction events are not unusual occurrences in solar system dynamics. This phenomenon happens to planets, to spacecraft, to any object whose orbit eventually takes it behind the Sun from our observational perspective. Mars experiences superior conjunction every 26 months. Venus goes through it approximately every year and a half. We routinely lose contact with our Mars rovers and orbital spacecraft for weeks at a time during these predictable periods, and mission planners account for it well in advance. Commands get uploaded before the blackout. Systems enter safe mode. Engineers wait patiently. It is inconvenient but entirely predictable and manageable. What makes this particular situation profoundly different is the nature of the object in question and the bizarre timing of events surrounding its disappearance. Consider the sequence carefully. 3I/Atlas was discovered on July 1, 2025 by the Atlas Survey Telescope in Chile, an automated system designed to scan the skies for potentially hazardous asteroids. From that moment of discovery, it immediately became the focus of intense international scrutiny. Initial observations suggested something highly unusual about its chemical composition. Follow-up spectroscopy performed with the Keck telescopes in Hawaii revealed emissions of nickel and cyanide in ratios that matched nothing in our extensive solar system database. The James Webb Space Telescope observed it in early August and discovered a coma absolutely dominated by carbon dioxide in an 8-to-1 ratio with water, the highest concentration ever recorded in any comet ever studied, sitting 6 standard deviations above established norms. Then came the detailed trajectory analysis. Multiple independent research groups calculated its precise orbit and realized with growing surprise that it approached remarkably close to Venus, Mars, and Jupiter, a configuration with cumulative probability of less than 0.005%. Its orbital plane tilted only 5 degrees from the ecliptic, the flat plane where planets orbit, another statistically improbable configuration. Questions multiplied exponentially faster than answers could be generated. And now, at the exact moment of perihelion when solar heating should force any hidden volatiles to explosively reveal themselves, when the comet should be at its most spectacularly active and most readily observable, it vanishes completely behind our sun. Coincidence? Perhaps the laws of celestial mechanics truly do not care about human curiosity or dramatic timing. Orbits follow paths determined purely by gravity and momentum, not by any consideration for observers or narrative tension. 3I/Atlas did not consciously choose to reach perihelion during superior conjunction. It simply followed the mathematical path carved through spacetime by its velocity vector and the sun's overwhelming gravitational influence. But coincidences have developed a disturbing habit of accumulating around this particular object, and some researchers are beginning to seriously question whether the word coincidence still appropriately applies. There exists another element worth considering, one that adds a strange layer of synchronicity to the October timeline. On October 21st, just 8 days before 3I/Atlas reached perihelion, Earth experienced a new moon phase. For those not intimately familiar with lunar cycles, a new moon occurs when the moon passes directly between Earth and the sun, rendering our natural satellite invisible to observers. The side facing Earth sits entirely in shadow. The moon effectively disappears from the night sky, creating the darkest possible conditions for astronomical observation. And during this particular new moon, something else happened simultaneously. 3I/Atlas reached what astronomers precisely define as superior conjunction with the sun at nearly the identical moment. The moon disappeared. The comet disappeared. Both objects occulted by our star within mere hours of each other, creating an alignment in the constellation Virgo with the sun, moon, and 3I/Atlas forming a nearly perfect geometric line stretching across millions of miles of solar system space. Now, I want to be clear that I am not promoting astrological interpretations, but I can certainly appreciate the poetic resonance of such a moment. A new beginning represented by the new moon, a hidden visitor from beyond, a cosmic reset button of sorts, all occurring simultaneously in a rare confluence. Some observers inclined toward energetic or metaphysical frameworks have suggested this represents a powerful moment of convergence, a meeting of celestial forces that might influence events on Earth or reveal hidden truths about the comet's nature and purpose. I will leave such interpretations to those who find personal meaning in celestial alignments and sacred geometry. But I will note something significant. The timing struck even professional astronomers, scientists who spend entire careers analyzing orbital mechanics and celestial events, as genuinely noteworthy. When you dedicate your professional life to understanding the mathematics of motion in space, you develop a refined intuition for what feels statistically normal versus what registers as unusual. Multiple researchers have mentioned in private conversations, in public lectures, and in published papers that the October convergence produced an uncanny feeling, not impossible by any means, not even particularly improbable when you rigorously calculate the numerical probabilities, but unusual in a subtle way that makes experienced scientists pause and wonder if they might be missing something important in their analysis. Now we enter more speculative territory, examining the theories that have proliferated across online forums and within certain academic circles about what might be happening during this blackout period while 3I/Atlas remains hidden from view. The most prominent voice advancing unconventional hypotheses belongs to Avi Loeb, the Harvard astrophysicist who has built a reputation for never shying away from controversial ideas. Throughout the summer and fall, Loeb and his research collaborators published a series of scientific papers and blog posts suggesting that 3I/Atlas could represent something more than a natural comet formed billions of years ago in another star system. They have proposed, cautiously and with appropriate scientific hedging, that it might constitute a technological artifact, possibly even one operating with what could be interpreted as hostile intent under a framework known as the dark forest hypothesis. This hypothesis, popularized in science fiction but taken seriously by some researchers studying the Fermi paradox, proposes that intelligent civilizations remain deliberately silent and hidden to avoid detection by potential predators prowling the galaxy. Any probe sent to reconnoiter another star system would, under this framework, operate covertly, disguised as a natural object. A comet, for instance, would make an ideal camouflage. Most astronomers working in planetary science dismiss this idea with varying degrees of patience and irritation. They point to the obvious cometary activity, the visible outgassing creating the coma, the spectroscopic signatures of familiar molecules like carbon dioxide, water vapor, and cyanide. They argue forcefully that 3I/Atlas fits, perhaps imperfectly but adequately, within the parameters of a natural albeit highly unusual interstellar comet. But Loeb counters with an thought experiment worth considering. If you were an advanced civilization designing a reconnaissance probe intended to enter another solar system while remaining undetected, how would you approach the engineering challenge? You would coat it with ice and dust to mimic natural appearance. You would engineer it to outgas material when heated, perfectly mimicking a comet's observed behavior. You would calculate a trajectory that appears entirely natural, perhaps even using gravitational assists from the very planets you wish to study more closely. And if you wanted to fundamentally change course, to break and enter a bound elliptical orbit around the target star rather than shooting back out into interstellar space on your original hyperbolic trajectory, when would you perform such a maneuver? During superior conjunction, naturally. When the system's inhabitants cannot observe you. When their star blocks every telescope and masks any anomalous acceleration or thrust signature. This is where speculation becomes simultaneously thrilling and deeply troubling for those who take it seriously. Loeb has calculated that if 3I/Atlas were to utilize what orbital mechanics specialists call a solar Oberth maneuver, a high-thrust braking burn performed at perihelion to maximize fuel efficiency, it could potentially adjust its trajectory substantially during this blackout period. When the object reemerges in December, careful observers would measure its orbit with precision and potentially discover it has been gravitationally captured by the Sun, no longer following a hyperbolic escape trajectory but instead tracing an elliptical path that permanently keeps it within our solar system. Such a maneuver would require significant thrust, substantial energy expenditure, but not beyond conceivable capabilities for an advanced propulsion system built by a civilization with even a few centuries more technological development than our own. And the evidence would be absolutely unmistakable to any astronomer performing careful position measurements. If 3I/Atlas emerges from behind the Sun following a trajectory different from the one precisely predicted by gravitational calculations, every alarm bell in the international astronomical community would start ringing simultaneously. We would know, without any possibility of doubt, that something intervened. We would know we are not alone in this galaxy. We would know we are being actively watched, studied, perhaps evaluated by intelligences from beyond our solar system. Before we spiral too far down speculative pathways, let me ground this discussion with essential perspective. The vast majority of professional astronomers, the scientists who dedicate careers to studying comets and asteroids and interstellar objects, consider the artificial probe hypothesis extraordinarily, vanishingly unlikely. The evidence supporting 3I/Atlas being a natural comet, despite its genuinely unusual properties, remains scientifically strong. Comets display remarkable diversity. Interstellar comets, formed in alien planetary systems with radically different chemical compositions and radiation environments, could easily exhibit properties we have never encountered before in our limited sample of solar system objects. The carbon dioxide dominance probably indicates formation beyond the carbon dioxide frost line in its home system, in regions where temperatures allow CO2 to condense but water remains gaseous. The unusual nickel emissions perhaps result from unique mineral compositions in the protoplanetary disk where this object originally formed billions of years ago. The trajectory, while statistically rare, is not impossible. In a galaxy containing hundreds of billions of stars, each potentially ejecting countless comets and asteroids into interstellar space, even 0.005% probabilities will eventually, inevitably occur. Occam's razor, the principle suggesting the simplest explanation usually proves correct, strongly favors a natural but chemically exotic comet as the most likely interpretation. However, Occam's razor cuts in multiple directions. If we inhabit a universe where intelligent life exists elsewhere, and the statistical arguments strongly suggest it does, and if such life develops technological capability for interstellar exploration, then artificial probes and reconnaissance craft should occasionally pass through our solar system. The statistical argument supporting natural explanations works equally well supporting the possibility of artificial visitors. So while the default scientific assumption should always initially favor natural explanations, we must also remain genuinely open to evidence that might contradict those comfortable assumptions. And this is precisely what makes the December observations so absolutely critical. When 3I/Atlas reemerges from behind the Sun, multiple telescopes worldwide will be waiting, tracking systems calibrated, observation schedules coordinated. Ground-based observatories will measure its position with exquisite precision, comparing observed trajectory data to the orbit predicted from pre-perihelion observations. Any deviation, any unexpected change in velocity or directional vector, will become immediately apparent to researchers. Space-based telescopes like Hubble and James Webb will examine its spectrum and brightness levels, searching for changes in chemical composition or activity levels that might indicate something unusual occurred during the hidden weeks. If the comet underwent a completely natural perihelion passage exactly as expected, these observations will confirm it clearly. The orbit will match predictions within measurement error. The spectral signature will show increased outgassing from intense solar heating, then gradually decrease as it moves away from the Sun and temperatures drop. Everything will make perfect sense, fitting established models. But if something else happened during those hidden weeks, if an artificial maneuver occurred or some other form of intervention took place, the December data will reveal it unambiguously. We will observe an orbit that does not match gravitational predictions. We will detect evidence of non-gravitational acceleration beyond what cometary outgassing can possibly explain through natural physics. We might observe changes in the object's orientation or rotation rate that cannot be explained by natural torques. And if we observe those things, if the accumulated evidence points unambiguously toward artificial intervention, then absolutely everything changes for humanity. The conversation shifts instantly from academic debate among specialists to existential reckoning for our entire species. We would face questions that humanity has contemplated philosophically for centuries but never had to answer with immediate practical urgency. Are we alone in this vast universe? Are we being actively studied by others? Are we safe? What should we do next? How do we respond? For now, though, we wait. We exist in a peculiar state of suspended curiosity, knowing that something scientifically significant is unfolding, but completely unable to observe it directly. We wait while 3I/Atlas, whatever it truly represents, bathes in the Sun's intense radiation at close range, potentially undergoing transformations we cannot measure or document. We wait and wonder whether the universe is about to reveal one of its greatest secrets, an answer to one of humanity's most profound questions, or whether we are simply observing a very unusual comet exhibiting very unusual but entirely natural behaviors. The ambiguity is absolutely maddening for scientists and enthusiasts alike. The anticipation feels almost electric, and the clock ticks steadily forward toward December, when the cosmic veil will finally lift and we will see exactly what emerges from the other side of our sun. This is the moment we collectively find ourselves inhabiting. Not quite knowledge, not quite ignorance, somewhere suspended in between, hanging in the space of possibility, waiting for the cosmos to reveal its hand and show us truth. If you are still watching, I need you to do something right now. Leave a comment telling me whether you think 3i/Atlas is natural or artificial. What does your intuition tell you? And make absolutely sure you have hit that like button because this content needs to reach as many people as possible. The implications are too significant to ignore. Now let me tell you about what was happening to Earth itself during mid-October. Because while 3i/Atlas was approaching its hidden rendezvous with the Sun, our own planet found itself caught in a barrage of solar activity unlike anything we had experienced in months. Between October 16th and October 21st, Earth endured multiple M-class solar flares erupting from a rapidly growing sunspot group, each one more powerful than the last. 3 separate coronal mass ejections launched from the Sun's surface, each one carrying billions of tons of magnetized plasma across 93 million miles of space, all aimed directly at our planet. NOAA, the National Oceanic and Atmospheric Administration, issued a G2 geomagnetic storm warning, then quietly upgraded their internal models as incoming data revealed the impacts might be considerably stronger than initially anticipated. And right in the middle of this solar assault, as Earth's protective magnetic field buckled and flexed under the electromagnetic onslaught, 3i/Atlas reached superior conjunction with the Sun during the new moon. The timing made even skeptical scientists nervous. Let me paint this picture with more clarity. Solar flares are not unusual phenomena. Our star undergoes an 11-year cycle of magnetic activity, and we currently find ourselves near solar maximum, the peak of cycle 25. During these active periods, sunspot groups form and dissipate across the Sun's surface. Magnetic field lines tangle and snap, releasing energy in spectacular bursts of radiation and charged particles that stream into space. We expect this. We monitor it continuously. We maintain entire government agencies dedicated to space weather forecasting and protecting technological infrastructure. But the specific sequence of events in mid-October stood out as unusual even to experienced space weather forecasters. The sunspot group that spawned these flares grew with alarming rapidity, expanding to several times Earth's diameter within just days. It rotated into what forecasters call geo-effective position, meaning it faced directly toward our planet, ensuring that any eruptions would strike us square on rather than missing into empty space. And it did not stop producing flares. October 16th saw the first major eruption, an M-class flare that sent ultraviolet and X-ray radiation streaming toward Earth at light speed, arriving just 8 minutes after the explosion. Radio operators worldwide noticed disruptions in high-frequency communications. Satellite controllers logged anomalies in spacecraft systems. Nothing catastrophic occurred, but the effects were distinctly noticeable. Then came the coronal mass ejections, the slower-moving but far more dangerous component of solar storm systems. These massive clouds of magnetized plasma take days to traverse the distance between Sun and Earth, and forecasters tracked 3 of them converging on our planet within a narrow time window. October 19th, 20th, and 21st saw 3 separate impacts in 3 consecutive days, with the final impact arriving just hours before the new moon, just hours before 3i/Atlas slipped behind the solar disk and vanished from our view. When that plasma struck Earth's magnetosphere, our planet's protective magnetic bubble compressed dramatically. The magnetic field lines that normally extend tens of thousands of miles into space got pushed back violently toward the planet's surface. Auroras danced spectacularly across the sky at unusually low latitudes, visible as far south as the northern United States and Central Europe, delighting photographers but signaling serious space weather impacts. But the visible light show represented merely the surface manifestation of deeper, more significant changes occurring in Earth's magnetic environment. Earth's radiation belts, those donut-shaped regions of trapped high-energy particles surrounding our planet like invisible shields, became supercharged. For about a week leading up to October 13th and 14th, the radiation belt flux remained at extraordinarily elevated levels, well above normal background measurements. Then, on October 13th and 14th, something called an ion precipitation event occurred. The trapped particles suddenly dumped into the upper atmosphere in a cascade, releasing accumulated energy that rippled through the magnetosphere like a shockwave. And immediately following that energetic release, two significant earthquakes struck our planet. A magnitude 6.5 near Papua New Guinea, a magnitude 6.3 in the Drake Passage between South America and Antarctica. Both earthquakes registered on October 16th, just as the solar activity was intensifying toward its peak. Now, I must be scientifically careful here. The connection between solar activity and seismic events remains highly controversial in mainstream geophysics. The standard view, taught in universities and supported by most evidence, holds that earthquakes result from tectonic stress accumulation and release, driven by the slow grinding of crustal plates over geological timescales. Solar storms occur on timescales of hours to days and involve electromagnetic energy, not direct mechanical force. There exists no widely accepted mechanism by which a coronal mass ejection could physically trigger an earthquake deep in Earth's crust. And yet, researchers like Stephen Burns, a geophysicist who has been meticulously tracking these correlations for years, keep finding persistent patterns in the data. Ion precipitation events followed within hours or days by major seismic releases. Low solar wind density periods coinciding with statistical upticks in high-magnitude earthquakes. It is not proof by any scientific standard. It is not even particularly strong evidence. But the correlations appear persistently enough across decades of data to make thoughtful researchers wonder whether we might be missing something fundamental about how energy flows through interconnected geophysical systems. The October sequence fit precisely the pattern Burns has been documenting. Supercharged radiation belts, sudden energetic discharge, major earthquakes within hours, and then, as if following a script, another punch to the magnetosphere from the incoming coronal mass ejections, recharging the radiation belts and potentially setting up the system for another release cycle. The timing alignment with 3I/Atlas superior conjunction might be completely meaningless. Space weather and comet orbits operate on entirely different physical principles, governed by different forces. But humans remain pattern-seeking creatures by evolutionary design. When unusual events cluster together temporally, we cannot help but wonder whether they share some hidden connection, some underlying cause we have not yet identified. Then there is the ongoing magnetic field situation, which has been quietly growing stranger for years but reached a particularly notable milestone in October 2025. The European Space Agency released comprehensively updated data from their Swarm satellite constellation showing how Earth's magnetic field has evolved from 2014 to 2025. The results were genuinely striking to geophysicists. The South Atlantic anomaly, that region off the coast of Brazil where Earth's protective magnetic field measures unusually weak, has expanded dramatically. In just 11 years, it has grown by an area roughly equivalent to Western Europe. The field strength in that region has dropped by 330 nanotesla, a significant measurable decrease. Simultaneously, other features of the magnetic field have shifted positions. The flux lobe over Siberia, where the field measures stronger than average, has increased by about 250 nanotesla. The flux lobe over Canada has weakened by more than 800 nanotesla. These are not trivial changes in a stable system. They represent a magnetic field in genuine flux, both literally and figuratively. The South Atlantic anomaly matters profoundly because it represents where Earth's protective shield exists at its weakest. Cosmic radiation, normally deflected harmlessly by the magnetic field, can penetrate deeper into the atmosphere in this region. Satellites passing through the anomaly experience dramatically higher rates of electronic glitches and component failures, requiring engineers to design around this known hazard. The International Space Station, when its orbit carries it over the anomaly, exposes astronauts to measurably increased radiation doses, requiring careful monitoring. And now the anomaly is expanding steadily eastward, reaching toward South Africa, growing in both geographic size and intensity of the weakness. It is not an immediate crisis by any means, but it represents a long-term trend that nobody fully understands or can confidently predict. Some geophysical models suggest it could represent early stages of a magnetic pole reversal, a dramatic event that occurs roughly every few 100,000 years on average and has not happened in 780,000 years. We are, statistically speaking, overdue for such a reversal. Other models suggest it represents merely a normal fluctuation, a temporary wobble in the geodynamo that will eventually correct itself naturally. Nobody knows with certainty which interpretation is correct. What we do know definitively is that during the October solar storm sequence, this weakened region of Earth's magnetic field got absolutely pummeled by charged particles. More cosmic radiation than usual penetrated through to the atmosphere. More energy dumped into complex geophysical systems. And all of this transpired while the North Magnetic Pole continued its steady accelerating march from Canada towards Siberia, moving from its historical drift rate of about 10 kilometers per year to its current pace of roughly 40 kilometers per year. The magnetic field is moving, shifting, weakening in some areas and strengthening in others. The anomalies are growing. And we experienced all this while being hit with 3 coronal mass ejections during the precise week that 3I/Atlas disappeared behind the sun during a new moon. The coincidence, the synchronicity, feels almost poetic to some observers. Those particularly attuned to energetic or metaphysical interpretations of celestial events saw the October convergence as deeply, profoundly significant. The new moon represents new beginnings in many traditions, a reset, a clearing of the cosmic slate. Superior conjunction places an object in direct alignment with the sun, theoretically amplifying its energetic influence on the solar system. The constellation Virgo, where this alignment occurred, carries traditional associations with purity, transformation, harvest, and hidden knowledge waiting to be revealed. Layer on top of that astronomical framework the intense solar activity, the magnetic field perturbations affecting our entire planet, the seismic releases, and you have assembled ingredients for something that feels cosmically important, even if articulating exactly why proves difficult. I am not here to validate or dismiss those metaphysical interpretations. I am here to document that multiple independent phenomena, operating on different timescales and through entirely different physical mechanisms, all peaked within a narrow window of days in mid to late October 2025. That is an observable fact. What it means, if anything beyond coincidence, remains genuinely open to interpretation. But let us return to more concrete scientific questions. Could the solar activity have directly affected 3I/Atlas as it passed through perihelion? Could the same coronal mass ejections that battered Earth have also interacted with the comet during its closest approach? The answer is yes, almost certainly. Solar storms do not exclusively affect Earth. They propagate as expanding bubbles throughout the entire inner solar system. When a coronal mass ejection erupts from the Sun, it carries with it an enhanced magnetic field and high-energy particle flux that expands outward at speeds of several hundred kilometers per second. As this magnetized bubble sweeps past planets, asteroids, comets, and spacecraft, it causes measurable effects across all these objects. Cometary tails get pushed around by the changing solar wind pressure. Dust particles in a coma experience additional forces beyond normal solar radiation pressure. The rate of sublimation might even change slightly as the particle flux increases and delivers additional energy to the surface. For a comet sitting at 1.36 astronomical units from the Sun during perihelion, positioned right in the heart of the inner solar system, the October solar storms would not have been gentle. The comet experienced significantly enhanced radiation, dramatically increased particle bombardment, and fluctuating magnetic field conditions. Now, would those effects be dramatic enough to fundamentally alter the comet's behavior? Would they change its trajectory or reveal hidden properties? Probably not through direct physical force. Solar storms are energetic on human scales, capable of disrupting satellites and power grids, but relatively weak when it comes to moving massive objects through space. 3I/Atlas, even if its nucleus measures only a few kilometers across, possesses enough mass and momentum that a coronal mass ejection would barely nudge it. The increased particle flux might enhance coma brightness slightly or alter dust distribution patterns, but those would be subtle effects easily explained by natural physics. If the comet is entirely natural, the October solar activity would not fundamentally change its behavior in ways that violate our understanding. But if the comet represents something else, if it contains sensors or scientific instruments designed to monitor its environment, those sensors would have registered the storm in exquisite detail. An artificial probe passing through the inner solar system during a period of heightened solar activity would collect extraordinarily valuable data about how stars behave during their active phases, how radiation environments vary, how magnetic fields fluctuate. It would represent a scientific opportunity, not a threat to the probe's integrity. This brings us to an uncomfortable realization worth considering seriously. If you were designing a scientific mission to study another star system comprehensively, you would absolutely want your probe to arrive during an active period in the star's magnetic cycle. You would want to measure the stellar wind variations, the magnetic field fluctuations, the particle fluxes and radiation levels that any potentially inhabited planet would experience during dangerous periods. Arriving during solar minimum, when the star is magnetically quiet and boring, would provide far less useful data than arriving during solar maximum when conditions are dynamic and potentially hazardous to biological life. And if you possess truly sophisticated mission planning capabilities, you would time your perihelion passage to coincide with a period of elevated stellar activity, maximizing the scientific data return from your reconnaissance mission. The October convergence, seen through that lens, appears less like cosmic coincidence and more like deliberate planning, like mission architecture designed by intelligence. I want to be clear. I am not claiming that is what happened. I am simply noting that the thought has crossed more than a few minds in the astronomical community, usually late at night after consuming too much coffee, when the strange coincidences pile up and the comfortable rational explanations start to feel inadequate. We also cannot ignore the human element in all of this. The October convergence did not just affect instruments and magnetic fields. It affected people directly. During periods of intense solar activity, medical researchers have documented that reports of disrupted sleep patterns increase. Heightened anxiety levels rise measurably. Unusual vivid dreams get reported more frequently. Emergency room visits for cardiac events show slight but statistically significant upticks. The mechanisms remain actively debated among researchers, but the correlations exist persistently in peer-reviewed literature. Our bodies contain iron in our blood, essential for oxygen transport. We have trace minerals distributed through our tissues. Electrical signals run constantly through our neurons, creating the phenomenon of consciousness itself. We are fundamentally electromagnetic beings living in an electromagnetic environment that usually remains stable. When that environment shifts dramatically during solar storms, we feel effects even if we do not consciously register the cause. And in mid-October, as the solar storm struck, as the magnetic field buckled under electromagnetic assault, as the new moon erased the sky and 3I/Atlas slipped from view, millions of people worldwide reported feeling distinctly off, restless, uneasy, experiencing a sense that something fundamental was about to change. Maybe it was purely the storms affecting human physiology. Maybe it was collective anxiety amplified and spread through social media networks. Or maybe, just maybe, we were sensing something our technological instruments had not yet confirmed, some change in the cosmic environment that our evolved senses could detect below conscious awareness. The geophysicist Stephen Burns captured this extraordinary moment in his analysis of the period. He carefully noted the complete sequence of events. the charged radiation belts dumping energy, the earthquakes following, the incoming high-speed solar wind stream that followed the coronal mass ejections. He observed that the new moon coincided precisely with 3I/Atlas superior conjunction and suggested, with a careful mix of scientific caution and genuine wonder, that October 21st represented a powerful energetic moment in ways we might not fully understand yet. He encouraged people to practice self-care, to spend time in nature when possible, to rest and reflect during this unusual period. Not because he believed in astrology or mysticism as explanatory frameworks, but because he recognized that human beings respond to environmental changes in ways we do not fully understand yet. Extraordinary environmental conditions call for mindful attention to our physical and mental well-being. It was a remarkably grounded, practical response to an extraordinary confluence of events. And now, as we move past that convergence point, as the solar storms have subsided and the magnetic field returns to its baseline state of slow drift and quiet anomalies, we are left with profound questions. Did anything significant happen during those days? Did the hidden comet respond to the solar barrage in unexpected ways? Will the December observations reveal changes we cannot yet imagine? Or was October 2025 simply a statistically unusual but ultimately meaningless clustering of independent events, the kind of thing that happens occasionally in a complex, chaotic universe governed by probability? We will not know with certainty until the comet reemerges and careful measurements can be made. If you have watched this far, you are clearly invested in this mystery. Do me a favor. Make sure that like button is smashed. Drop a comment telling me what you think is really happening. And watch until the very end, because what I am about to tell you about the observations made before the blackout will fundamentally change how you think about this object. Now let me tell you about the unprecedented observation campaign that unfolded on Mars in early October. October 3rd, 2025. While Earth prepared for incoming solar storms and astronomers watched 3I/Atlas approach its appointment with the Sun, a different kind of observation was taking place 19 million miles away. At Mars, an unprecedented coordinated campaign was unfolding involving multiple spacecraft and even the rovers on the surface. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter had been quietly repositioned over preceding weeks, their cameras and spectrometers carefully calibrated for a target far fainter than the ruddy Martian surface they were designed to study. NASA's Mars Reconnaissance Orbiter received similar instructions, reprogramming its pointing systems for an unusual astronomical observation. Down on the surface, the Perseverance and Curiosity rovers tilted their massed cameras toward the sky, programmed to attempt observations that pushed the absolute limits of what surface-based instruments could achieve in the thin Martian atmosphere. This was not a casual scientific effort. This represented a coordinated interplanetary surveillance operation, and the target was our mysterious visitor as it sailed past the red planet at its closest approach. The results proved mixed, frustrating in some ways, and in other ways more intriguing than a clear success would have been. Mars Express and ExoMars Trace Gas Orbiter succeeded in their primary objective. They captured images showing 3I/Atlas against the starfield. The images were faint, grainy, requiring extensive processing to extract signal from noise, but they represented real scientific data. The cameras designed to photograph a bright planet from less than 200 miles away were instead pointed at an object 10,000 to 100,000 times fainter, sitting nearly 30 million kilometers distant across interplanetary space. That they detected anything at all represents a technical achievement worth celebrating in the space exploration community. Nick Thomas, the principal investigator for the CASIS camera on the Trace Gas Orbiter, called the observation very challenging in what might qualify as the understatement of the year. The processed images show 3I/Atlas as a streak. Not glamorous, not the kind of thing you would print as a poster, but scientifically valuable because it confirms position, brightness levels, and most importantly, continued activity. 3I/Atlas was still outgassing on October 3rd. It still possessed a visible coma. It was still behaving, at least superficially, like a comet should behave. But here is where things get genuinely interesting. The images revealed something unexpected in the comet's appearance that caught researchers' attention. Instead of a round, symmetric coma that you would expect from a uniformly sublimating nucleus rotating in space, the processed images showed clear asymmetry. The coma appeared slightly elongated with substantially more material extending in one direction than others, creating a distinctly lopsided appearance. Now, asymmetric comae are not particularly unusual in cometary science. Most comets show some degree of lopsidedness because their nuclei are irregularly shaped, rotating bodies with active regions concentrated in specific areas rather than uniformly distributed. As the nucleus rotates, different patches face the sun at different times, creating jets and plumes that push material outward in preferred directions, creating the observed asymmetry. So asymmetry alone is not alarming or anomalous. What specifically caught attention was the geometry of this asymmetry. The enhanced outgassing appeared to favor the sunward direction, which is backwards from what you typically observe. Normally, intense solar radiation and the solar wind push cometary material away from the sun, creating the iconic tail that always points in the antisolar direction. But 3I/Atlas seemed to be preferentially puffing more material toward the sun than away from it, defying the expected physics. The Keck observations from late August had hinted at this unusual pattern. The sunward-biased distribution of dust and gas visible in the nickel and cyanide emission maps suggested something atypical about how the comet responded to solar heating. The October images from Mars' orbit confirmed this pattern persisted over time. It was not a temporary phenomenon or measurement artifact. Explanations exist for this behavior within natural comet physics. If the nucleus does not rotate rapidly, if it is tidally locked or tumbling very slowly through space, the dayside hemisphere could remain constantly heated while the nightside stays perpetually cold and inactive. All the sublimation would occur on the sunward hemisphere, pushing material outward in that direction before the solar wind eventually catches it and sweeps it back into a more traditional tail configuration. It is a physically reasonable model that fits the observational data. The European Space Agency exercised appropriate scientific caution in their official statements following the Mars observations. They described the campaign as successful, providing valuable data on an interstellar object from a unique vantage point millions of miles from Earth. They noted the extreme faintness of the target and the impressive technical challenges their teams overcame to capture any data at all. They did not speculate publicly about the asymmetry or what it might mean. When pressed by science journalists hungry for compelling narratives, ESA spokespersons emphasized that comprehensive analysis of the data remained ongoing and that preliminary interpretations should be treated as tentative pending peer review and additional observations. Translation for those who speak bureaucratic science speak. We saw something genuinely interesting that does not quite fit expectations. We are not entirely sure what it means yet, and we are absolutely not going to stick our professional necks out with bold claims until we have substantially more information and multiple independent confirmations. This represents standard, appropriate scientific caution, the correct response when dealing with potentially extraordinary claims supported by limited data. But it also created a gap, an informational vacuum where speculation could flourish in the absence of definitive answers. And flourish it most certainly did across social media, forums, and blogs. NASA's Mars Reconnaissance Orbiter also attempted observations during approximately the same time frame, and here the story becomes frustratingly murky and incomplete. The spacecraft carries an extraordinarily powerful camera called HiRISE, the high-resolution imaging science experiment, capable of resolving features on the Martian surface down to approximately 30 centimeters. When pointed skyward instead of downward, it could theoretically capture substantially more detail of 3I/Atlas than the European orbiters managed with their less capable instruments. NASA publicly announced they would attempt the observation. They confirmed the spacecraft successfully executed the complex pointing maneuvers, rotating away from its usual nadir pointing orientation to track a faint moving target across the sky. And then, silence. Complete radio silence on the results. No images released to the public or scientific community. No official statements about whether the observation succeeded or failed. No data published for independent researchers to analyze and verify. No press releases capitalizing on public interest. This is not necessarily suspicious or indicative of a cover-up. Spacecraft operations involve enormous complexity with countless competing priorities. Data processing, especially for unusual observations pushing instrumental limits, takes substantial time and careful validation. Mission teams maintain priorities beyond satisfying public curiosity or feeding the 24-hour news cycle. Funding comes from taxpayers, but scientists ultimately serve the pursuit of knowledge, not entertainment. But the absence of any Mars reconnaissance orbiter imagery weeks and then months after the observation window does strike experienced space watchers as genuinely unusual. Typically, when a successful observation of a high-profile target occurs, NASA releases at least preliminary images relatively quickly, capitalizing on public interest while demonstrating the scientific value of their expensive missions to the taxpayers funding them. The complete silence suggests either technical failure, with the observation attempt producing no usable data, or alternatively, something in the captured data that requires extraordinarily careful review and validation before public release. Which possibility seems more likely remains a matter of speculation and personal interpretation. The surface rovers, Perseverance and Curiosity, faced even more daunting challenges in their observation attempts. Pointing cameras designed for close-range geological imaging at a faint comet millions of miles distant fundamentally violates the design parameters of those instruments. The sensitivity is completely wrong for such observations. The exposure times required would be impractically long. The thin Martian atmosphere, while far less substantial than Earth's, still scatters enough light to degrade faint astronomical observations. These rovers were built to photograph rocks and soil samples at arm's length, not to perform astrophysics. Nevertheless, mission planners programmed both rovers to make the attempt because the scientific opportunity was simply too valuable to ignore. Any data, even marginally useful data, would contribute to the comprehensive observation campaign. The results, as expected, proved disappointing but not entirely fruitless. Both rovers captured images of the appropriate sky region during the window when 3I/Atlas should have been visible from their locations. Image processing revealed something. Not a clear detection, not a definitive image, but statistical evidence suggesting a faint signal above background noise in approximately the right location. It is the astronomical equivalent of squinting at a blurry photograph and thinking you can maybe see something that might be there. These marginal detections cannot tell us much about the comet's properties or behavior. They merely confirm, with admittedly low confidence, that something was present in that region of sky at that time. For the scientific record, that counts as success. For public communication and narrative purposes, it feels frustratingly inconclusive. The rovers tried. They gave it their best effort. The instruments simply were not designed for this application, and physics has limits that cannot be overcome through determination alone. So we have fragmentary observations from Mars orbit showing an active comet with an asymmetric, possibly sunward-biased coma. We have silence from NASA's highest-resolution camera. We have marginal detections from surface rovers pushing their instruments beyond design specifications. And we have a comet that then disappeared behind the Sun for weeks of unobservable perihelion passage. The October 3rd observations represent our last clear look at 3I/Atlas before the blackout, our final opportunity to gather data before it vanished into the Sun's glare. And those observations, fragmentary and frustrating as they are, do not provide the clear answers everyone wanted. They raise additional questions instead. Why the asymmetry? Why the sunward bias? Why does this object keep defying expectations in subtle but persistent ways? Natural explanations exist for every anomaly individually. But the accumulation of anomalies, each requiring specific conditions to explain, begins to strain credibility for some observers. At what point does a string of unlikely but possible coincidences transform into a pattern suggesting something more fundamental might be occurring? Different scientists draw that line at different places based on training, temperament, and personal philosophy of science. Conservative researchers, the majority, argue we have not reached that threshold yet. Every observation remains explicable within natural frameworks. Unusual chemistry, yes. Atypical behavior, certainly. But nothing definitively requiring exotic explanations. Extraordinary claims require extraordinary evidence, and we simply do not have that evidence yet. Caution, skepticism, and adherence to established frameworks serve science well. They protect us from premature conclusions and embarrassing errors. But a minority of researchers, including some with impeccable credentials and decades of experience, quietly wonder if the conservative approach might cause us to miss something genuinely extraordinary hiding in plain sight. What if we are so committed to natural explanations that we fail to recognize artificial signatures when they appear? What if the extraordinary evidence we demand looks exactly like what we are already observing, and we simply refuse to acknowledge it because the implications seem too dramatic? This tension, this productive disagreement within the scientific community, represents exactly how science should function when confronting genuinely novel phenomena. Multiple perspectives, vigorous debate, careful analysis of evidence, and ultimately, letting nature itself provide the answer through additional observations. December observations, when 3I/Atlas reemerges, will significantly advance this debate one direction or another. Before we move forward chronologically, I need to tell you about something else that happened during October, something that added yet another layer of strangeness to an already bizarre situation. Multiple amateur astronomers and some professionals reported observing what they described as companion objects or fragment fields traveling alongside 3I/Atlas. These reports remain unverified through official channels, but they are persistent enough and come from credible enough sources that they deserve attention and discussion. The first reports emerged in late September from amateur astronomers in the southern hemisphere using modest telescopes and sensitive CCD cameras. They noticed what appeared to be additional faint objects in proximity to the main comet, moving through space on similar trajectories. Initially, these were dismissed as background stars or image processing artifacts. When you are hunting for extremely faint objects at the limits of detection, false positives occur frequently. Stars that happen to align with the comet's path. Cosmic rays striking the camera sensor. Hot pixels. Noise patterns that the human brain interprets as meaningful signals. But the reports kept coming from independent observers using different equipment at different locations. And some of the objects appeared to move with the comet across multiple nights of observation, maintaining consistent positions relative to the main nucleus rather than staying fixed like background stars would. This suggested, tentatively, that they might be physically associated with 3I/Atlas rather than chance alignments. Several interpretations exist for such observations, assuming they represent real phenomena rather than systematic observational errors. Comets sometimes fragment, splitting into multiple pieces that travel along similar but slightly divergent trajectories. We have observed this behavior numerous times in solar system comets. The infamous comet Shoemaker-Levy 9 that collided with Jupiter in 1994 had fragmented into more than 20 distinct pieces, creating a spectacular string of impacts visible from Earth. If 3I/Atlas experienced fragmentation at some point during its journey, either before entering our solar system or after, companion objects traveling nearby would be entirely natural and expected. Another possibility involves dust trails and particle streams. Comets continuously shed material as they outgas. Most of this material consists of tiny dust particles and ice crystals that form the visible coma and tail. But occasionally, larger chunks detach from the nucleus. Centimeter-sized to meter-sized particles that maintain roughly similar orbits to the parent body for extended periods. From a distance, concentrations of these larger particles might appear as discrete objects or elongated fragment fields, especially when observed at the limits of instrumental sensitivity. A third, more speculative interpretation suggests the companion objects might not be fragments or debris at all, but rather separate entities traveling in formation with the primary object. This interpretation obviously carries implications that make mainstream astronomers deeply uncomfortable. If 3I/Atlas represents a natural comet, why would separate objects travel alongside it in apparent coordination? Natural explanations struggle here. Gravitational capture seems unlikely given the comet's trajectory and the weak gravitational field of a small nucleus. Random chance, multiple objects ejected from the same source system following nearly identical paths, strains probability. But if 3I/Atlas represents something other than a purely natural comet, companion objects make substantially more sense. A probe traveling through interstellar space might deploy smaller subprobes or instruments packages. A reconnaissance mission might involve multiple components working in coordination. Science fiction authors have explored these concepts for decades, but they remain firmly in speculative territory when discussing real observations. The critical question: are the companion object reports actually real? Do they represent genuine detections or observational artifacts amplified by wishful thinking and confirmation bias? The honest answer is we do not know with certainty. The observations have not been confirmed through official channels. No major observatory has released data showing these objects. No peer-reviewed papers have analyzed them. They exist in that frustrating liminal space of unconfirmed reports from credible sources, tantalizing but unverifiable. Social media erupted with claims and counterclaims throughout October. Some users posted processed images claiming to show the companion objects clearly. Others argued the images showed nothing but noise and artifacts. Accusations of manipulation and conspiracy thinking flew in both directions. The signal-to-noise ratio in public discourse dropped essentially to zero, making it nearly impossible for interested observers to separate potential signal from overwhelming noise. Professional astronomers largely avoided engaging with these claims publicly, not necessarily because they dismissed them entirely, but because commenting on unverified observations opens one to criticism regardless of position taken. Confirm the observations too readily, and you risk professional credibility if they prove false. Dismiss them too quickly, and you might miss something genuine while appearing closed-minded. Silence often represents the safest professional strategy when dealing with controversial, unconfirmed claims. Privately, though, some astronomers admitted the reports were interesting enough to warrant follow-up observations if telescope time could be secured. And a few did attempt confirmation observations in early to mid-October before the Superior Conjunction blackout. Whether those attempts succeeded or failed, whether data exists somewhere showing these objects definitively or ruling them out conclusively, remains unclear in the public domain. What we can say definitively is that multiple independent observers reported seeing something unusual in the vicinity of 3I/Atlas during its approach to perihelion. What they saw, whether real or artifactual, represents another mystery added to the growing list surrounding this object. December observations will hopefully provide clarity, assuming the companion objects, if real, remain visible after perihelion passage. Now I need to address something that has been building throughout this entire narrative, an undercurrent of unease that many people felt during October but few could articulate clearly. Beyond the scientific measurements, beyond the orbital calculations and spectroscopic analyses, there existed a widespread sense that something significant was occurring, something that transcended pure astronomy and touched on deeper questions about humanity's place in the cosmos. Online forums exploded with discussion throughout October. Not just astronomy forums populated by enthusiasts and professionals, but mainstream social media platforms, subreddits, discussion boards covering topics far removed from science. People were talking about 3I/Atlas in ways that surprised even those of us who follow space news closely. The comet became a cultural phenomenon, a focal point for anxieties and speculations about contact, disclosure, humanity's readiness to confront cosmic realities. Some of this attention stemmed from Avi Loeb's public statements and papers discussing the artificial probe hypothesis. Loeb has a talent for public communication, an ability to present speculative ideas in ways that capture imagination while maintaining scientific framing. His involvement lent credibility to discussions that might otherwise be dismissed as fringe conspiracy thinking. When a Harvard astrophysicist seriously discusses the possibility of an interstellar probe disguised as a comet, people pay attention. But the cultural moment transcended any single researcher's influence. Something about the October convergence, the timing, the accumulated anomalies, the mystical alignment during the new moon, resonated with people on levels beyond pure rationality. Humans are not purely rational creatures. We respond to symbols, to synchronicities, to moments that feel pregnant with meaning even when we cannot logically justify that feeling. The October 21st new moon superior conjunction became, for many, a symbolic moment of transition, a threshold, a cosmic pause button pressed just before something significant. New Age communities discussed energetic shifts and consciousness transitions. Religious communities debated signs and prophecies. Skeptical communities mocked both groups while nervously checking astronomy websites for updates. The discourse sprawled across every platform and perspective, united only by shared attention focused on this enigmatic visitor from beyond. Psychologists and sociologists will probably spend years analyzing the October 3I/Atlas phenomenon as a case study in collective attention, meaning-making, and how societies respond to genuine uncertainty about cosmically significant questions. We live in an era where belief in extraterrestrial intelligence has become mainstream. Polls consistently show that majorities in most developed countries believe intelligent life exists elsewhere in the universe. The U.S. government has confirmed the existence of unidentified aerial phenomena that display capabilities beyond known human technology. The scientific search for extraterrestrial intelligence has moved from fringe speculation to legitimate research funded by major institutions. In this cultural context, an interstellar object exhibiting unusual properties arrives at a symbolically significant moment during heightened solar activity, and people naturally wonder if this represents the moment, the long-anticipated first contact scenario we have rehearsed countless times in fiction but never experienced in reality. Is this how it happens? Not with dramatic flying saucers landing on the White House lawn, but with a mysterious comet that might be something else, observed by scientists who carefully hedged their statements with caveats and uncertainties. The ambiguity might be the most maddening aspect. If 3I/Atlas were obviously artificial, showing clear technological signatures beyond any doubt, we would collectively adjust to that new reality however traumatic the adjustment might be. If it were obviously natural, fitting comfortably within established frameworks, we would file it away as interesting but not paradigm-shifting. But this in-between state, this genuine uncertainty where both interpretations remain plausible, creates cognitive dissonance and anxiety that manifests in countless ways across the cultural landscape. Make sure you are still with me here. If this mystery captivates you as much as it should, you need to be subscribed to this channel because I will be covering every single development as December approaches and we finally get answers. Drop a comment right now telling me how you are feeling about all this. Excited? Anxious? Skeptical? I want to know. And that like button better be glowing blue because understanding what we are dealing with here could be the most important thing happening on this planet right now. Let me tell you what we know about the James Webb Space Telescope observations in more detail, because these measurements sit at the heart of the scientific mystery. In early August 2025, Webb turned its extraordinarily sensitive infrared instruments toward 3I/Atlas, specifically using the NIRSpec instrument designed for spectroscopic analysis. The goal was to determine the precise chemical composition of the gases escaping from the comet's nucleus, to create a detailed inventory of molecules present in the coma. The results shocked researchers. The carbon dioxide to water ratio measured 8:1, meaning for every water molecule detected, 8 carbon dioxide molecules were present. To understand why this is extraordinary, you need context about typical cometary composition. Comets formed in our solar system show enormous diversity in chemistry depending on where and when they formed. But across that entire range of diversity, water dominates the volatile inventory in almost every case. Water ice comprises the primary frozen volatile in cometary nuclei. When heated by the sun, water sublimates first and most abundantly, creating the visible coma. Carbon dioxide exists in solar system comets too, sometimes in substantial quantities, but almost always subordinate to water. The ratio typically runs anywhere from 1 part carbon dioxide to 10 parts water, up to perhaps 1 to 2 in the most carbon dioxide-rich examples. 3I/Atlas flips this completely. Carbon dioxide absolutely dominates. Water exists almost as a trace constituent, a minor component in a chemistry dominated by carbon-bearing molecules. The statistical analysis showed this composition sits 6 standard deviations from the mean of all previously measured comets. 6 sigma. In statistical terms, this represents the boundary of extreme outliers, observations so far from average that they occur purely by chance less than once in a billion trials. Does this prove artificial origin? Absolutely not. It proves unusual chemistry, formation in a system with radically different conditions than our solar system. The star that originally hosted 3I/Atlas might have been carbon-rich, flooding its protoplanetary disk with carbon compounds. The comet might have formed in a region beyond where water ice condenses but where carbon dioxide remains gaseous, leading to selective incorporation of CO2 over H2O. Physical chemistry offers pathways to explain unusual ratios through natural processes. But it is undeniably weird. It expands our understanding of cometary diversity to include chemical compositions never observed before. And it raises questions about how formation conditions in other stellar systems might differ from our own in ways we have not yet fully appreciated. When you add this chemical weirdness to all the other unusual properties, the cumulative picture becomes increasingly difficult to dismiss as merely an interesting outlier. The nickel emissions observed by the Very Large Telescope and confirmed by the Keck Observatory add another layer of strangeness. Comets do emit metals. We have detected iron, nickel, sodium, and other elements in cometary spectra for decades. These metals exist as trace constituents in the rocky and dust components of cometary nuclei. When heated, small amounts of these materials can vaporize and emit characteristic spectral lines. But the ratios matter enormously. The nickel emission lines in 3I/Atlas's spectrum appear unusually strong relative to other elements. Not just present, but prominent. Some researchers noted that the ratios resemble industrial alloys more than primordial cosmic abundances. Again, this does not constitute proof of artificiality. It might reflect unusual metallicity in the source star system. It might indicate formation processes that concentrated nickel preferentially. But it is another data point that sits uncomfortably in the unusual column. Another feature that requires explanation beyond the typical comet story. Another reason why researchers keep studying this object with intensity bordering on obsession. Every new measurement should, theoretically, narrow the range of possible interpretations. Instead, with 3I/Atlas, each new measurement seems to expand the mystery, revealing new layers of strangeness that demand explanation. The trajectory analysis deserves deeper exploration because the mathematics tell a compelling story. When researchers calculate the orbit of 3I/Atlas, they begin with careful position measurements over time. Where was the object at time 1, time 2, time 3, extending across weeks and months? These positions, combined with the physics of gravitational motion, allow calculation of the complete orbital path, past and future. 3I/Atlas follows a hyperbolic trajectory, meaning it is not gravitationally bound to the Sun. It came from interstellar space, it is making a single pass through our solar system, and it will return to interstellar space on the outbound leg. The eccentricity of approximately 6.08 indicates a strongly hyperbolic orbit, moving at 57 kilometers per second relative to the solar system's reference frame. But the specific geometry of that trajectory is what raises eyebrows. The orbital plane tilts only 5 degrees from the ecliptic, the flat plane where planets orbit. Most interstellar objects should arrive from random directions showing no preference for the ecliptic. The ecliptic represents an arbitrarily tiny slice of the three-dimensional sphere of possible approach directions. Yet 3I/Atlas arrives nearly within that plane. Additionally, its path carries it relatively close to multiple planets. Venus, Mars, Jupiter all received reasonably close approaches. None threatening but close enough for spacecraft to observe and for gravitational perturbations to slightly modify the trajectory. The combined probability of arriving near the ecliptic and passing close to multiple planets simultaneously calculates to less than 0.005%, 1 in 20,000. Is this proof of artificiality? No. With potentially millions or billions of interstellar objects passing through the galaxy over geological time, 1 in 20,000 events will occur regularly. We might simply be lucky enough to observe one of the rare geometrically interesting cases. Selection bias might be at play too. Objects on ecliptic-aligned orbits passing near planets are more likely to be discovered because we have more observing assets concentrated near the ecliptic where our planets exist. But it is suspicious. It makes the pattern recognition circuits in human brains light up with "this seems non-random" alerts. And when combined with everything else, the unusual chemistry, the atypical behavior, the timing, it contributes to an overall picture that refuses to resolve into comfortable certainty. The Vera Rubin Observatory's accidental discovery of 3I/Atlas before the official Atlas discovery deserves mention here too. Vera Rubin, recently commissioned and conducting science validation observations, detected the comet on multiple nights in late June 2025. The object appeared in their data pipeline, flagged by automated systems as a moving object warranting further attention. But the Vera Rubin team was focused on validating systems, not immediately announcing every detected object. Their protocols required verification, follow-up observations, orbital calculations before issuing public announcements. By the time they were ready to formally report the discovery, Atlas had already found it independently and claimed discovery credit. This story matters because it previews our immediate future. Vera Rubin Observatory, now fully operational, will discover dozens of interstellar objects every year. What was once rare and newsworthy will become routine. We will catalog a growing population of these visitors, learning whether 3I/Atlas represents a bizarre outlier or the first example of a common class of weird objects we simply had not detected before. If future interstellar visitors show similar properties, unusual chemistry, suspicious trajectories, we will need to seriously reconsider our assumptions. If they all appear boringly normal with 3I/Atlas standing alone as the anomaly, we can file it away as a statistical fluke, interesting but not paradigm-shifting. The next few years will be revelatory as our sample size increases from countable on one hand to statistically meaningful numbers. The cyanide and hydrogen cyanide detections add yet another dimension to the chemical story. HCN, hydrogen cyanide, is relatively common in comets. It forms readily in cold environments from carbon, hydrogen, and nitrogen, all abundant in interstellar space and protoplanetary disks. Finding it in 3I/Atlas surprised nobody. But the production rates measured by radio telescopes in September showed HCN outgassing increasing dramatically as the comet approached the Sun, climbing from about 1.5 times 10 to the 25 molecules per second to 4.5 times 10 to the 25 molecules per second in just 1 week. This rapid increase indicates either accelerating sublimation as temperatures rise, entirely natural, or possible fragmentation exposing fresh ice to sunlight, also natural, or changing activity patterns as different regions of the nucleus rotate into view. Again, explanations exist. But monitoring this chemical production over time provides clues about what is happening on and inside the nucleus, processes we cannot directly observe but can infer from the molecules we detect escaping into space. The coma asymmetry measured on September 15th, elongated in the antisolar direction with a visible dust tail, shows that by that date, 3I/Atlas was behaving more like a typical comet with material being pushed away from the Sun by radiation pressure and solar wind. This contrasts with the earlier Mars observations suggesting sunward-biased outgassing, raising questions about whether the comet's behavior changed over time or whether different measurement techniques at different wavelengths and sensitivities were seeing different aspects of a complex, three-dimensional structure. Comets are messy, complicated objects with jets and plumes pointing in multiple directions simultaneously. Interpreting partial observations of these complex structures presents genuine challenges even for experienced researchers. Now let me address the Oberth maneuver concept directly because this sits at the center of Avi Loeb's most provocative speculation. An Oberth maneuver represents a counterintuitive but mathematically sound orbital mechanics technique. When executing a propulsive burn to change velocity, doing so at the point of highest velocity, typically perihelion for a solar orbit, provides maximum efficiency. The reason involves kinetic energy. Kinetic energy scales with velocity squared, so adding 1 kilometer per second to an already fast-moving object changes its kinetic energy more than adding 1 kilometer per second to a slow-moving object. This means propellant expended at perihelion purchases more change in orbital energy than the same propellant expended elsewhere in the orbit. If anything wanted to break from a hyperbolic escape trajectory into an elliptical bound orbit around the Sun, the most efficient location to burn propellant is exactly at perihelion. And if you wanted to hide that maneuver from observers on Earth, executing it during superior conjunction when the Sun blocks all telescopes would be optimal timing. This is why Loeb's speculation, while wildly speculative by scientific standards, is not absurd. It represents mathematically sound reasoning about what an advanced intelligence would do if attempting covert orbital insertion. The fact that 3I/Atlas reaches perihelion during superior conjunction means the opportunity exists for such a maneuver, whether or not anything actually takes advantage of that opportunity. December observations will answer this question definitively. If 3I/Atlas emerges on the predicted hyperbolic trajectory, continuing outward toward interstellar space with no unexpected velocity changes, the Oberth maneuver hypothesis is falsified. The comet did nothing special behind the Sun. It was just a comet doing comet things. But if the trajectory shows deviation from predictions, if the orbit looks captured or significantly altered beyond what cometary outgassing can explain, we will know intervention occurred. And at that point, the conversation changes fundamentally and irreversibly. Every scientist, every government, every person on Earth will need to confront implications that most would prefer to indefinitely postpone. The dark forest hypothesis, mentioned earlier, deserves more thorough explanation because it provides philosophical context for why a probe might behave covertly. The hypothesis originates from science fiction, specifically Liu Cixin's three-body problem trilogy, but has been seriously discussed by scientists studying the Fermi paradox, the question of why we see no evidence of extraterrestrial civilizations despite strong statistical arguments suggesting they should exist. The dark forest hypothesis proposes that the universe resembles a dark forest where every civilization represents a hunter moving silently, afraid to announce their presence. The reasoning goes, civilizations cannot know the intentions of other civilizations. Communication across interstellar distances takes centuries or millennia, far too slow for meaningful negotiation if conflict arises. The safest strategy might be preemptive elimination of any detected civilization before they become threats. Under these brutal assumptions, staying silent and hidden becomes the only rational survival strategy. Applied to interstellar probes, the hypothesis suggests that reconnaissance missions would operate covertly, gathering intelligence without announcing presence. Disguising the probe as a natural object, a comet for instance, provides ideal cover. If discovered and analyzed, it appears innocuous, just another ice ball wandering the galaxy. Only upon close examination would the truth potentially emerge. Does this mean 3I/Atlas is a dark forest probe? Obviously not proven. The hypothesis provides a framework for thinking about motivations and strategies that an advanced intelligence might employ. It makes the covert approach seem logical rather than paranoid. If you are going to send scouts to other star systems, you probably want them to avoid detection for as long as possible. But it is also possible, perhaps even likely, that civilizations capable of interstellar travel have moved beyond the dark forest mentality. Maybe the universe is not uniformly hostile. Maybe cooperation and peaceful coexistence represent stable strategies at galactic scales. Maybe any civilization surviving long enough to achieve interstellar capability has necessarily solved the problems that make the dark forest scenario seem plausible. We simply do not know. We have one data point, ourselves. We barely qualify as a technological civilization, still confined to a single planet, still divided into competing nation-states, still struggling with existential risks of our own creation. Extrapolating from our current state to predict the behavior of civilizations thousands or millions of years more advanced involves wild speculation masquerading as reasoning. What we can say is that 3I/Atlas offers an opportunity to gather actual data on this question rather than purely speculating. If it is natural, we learn about cometary diversity and interstellar object properties. If it is artificial, we learn that intelligence exists beyond Earth and that it employs specific observational strategies. Either answer provides value. The uncertainty, while uncomfortable, represents the exciting frontier of discovery. I want to pause here and talk directly to you watching this. We are living through a genuinely unique moment in human history. For the first time, we have the technological capability to detect and study interstellar objects visiting our solar system in real time. For the first time, we can seriously assess whether an object might represent artificial intelligence rather than dismissing the idea out of hand. Our instruments have reached sensitivity levels where these questions become empirically testable rather than purely philosophical. Embrace this uncertainty. Live in this question. Allow yourself to feel the excitement and anxiety of not knowing, because soon enough we will know, and this particular mystery will resolve one way or another. The moment of not knowing is fleeting and valuable. It connects us to every human who has ever looked at the night sky and wondered what lies beyond our world, what intelligence might exist among the distant stars, whether we are alone or accompanied in this vast cosmic arena. And when December comes, when the data arrives, when preliminary conclusions emerge and the truth begins to clarify, remember this moment. Remember what it felt like to genuinely not know the answer to a cosmically significant question. Remember the speculation, the debate, the hope and fear and wonder that characterized these weeks of waiting. Remember that you lived through this moment when humanity confronted one of its oldest and most profound questions with actual empirical investigation rather than pure philosophical speculation. Whether 3I/Atlas proves to be a bizarre but natural comet or something far more extraordinary, whether we remain alone or discover company in the cosmos, whether December brings confirmation or revolution, we will have participated in something genuinely important. We will have demonstrated that humanity can confront deep uncertainty about existential questions with curiosity and reason. We will have shown that we are ready as we can be, for whatever truths the universe chooses to reveal. The countdown continues. The solar blackout persists. The comet remains hidden behind our star, undergoing transformations we cannot yet observe. And we wait, with instruments ready and minds open, for the moment of revelation that approaches with each passing day. December is coming. Truth is coming. And humanity stands ready to receive it. Before I close this extended meditation on 3I/Atlas and its implications, I want to return once more to the human dimension of this story. Behind all the spectroscopy and orbital mechanics, behind the statistics and hypotheses, lie human beings experiencing genuine emotions about cosmic questions. Scientists who have dedicated careers to studying comets and asteroids, now confronting an object that defies easy categorization. Enthusiasts who have followed space news for decades, recognizing this might be the story they have been waiting for. Skeptics who see nothing unusual and grow frustrated with what they perceive as unfounded hype. Believers who feel vindicated by each anomalous measurement. All these perspectives are valid human responses to genuine uncertainty. We should not mock or dismiss any of them. The person who sees clear evidence of artificiality in the data is not foolish, merely interpreting incomplete information differently. The person who insists on natural explanation is not close-minded, merely maintaining appropriate scientific conservatism. The person who feels existential anxiety contemplating contact is not weak, merely responding honestly to profound implications. The person who feels excitement and hope is not naive, merely allowing themselves to experience wonder. We are all doing our best to make sense of something genuinely confusing and potentially significant. We lack complete information. We lack historical precedent. We operate from different epistemic frameworks and values. Disagreement is inevitable and healthy. What matters is maintaining respect for different perspectives while remaining committed to evidence as the ultimate arbiter of disputes. The 3I/Atlas phenomenon, the cultural moment surrounding this object, reveals something beautiful about humanity. We still care about big questions. We still wonder about our place in the cosmos. We still feel excitement about exploration and discovery. In an era often characterized as cynical and fragmented, millions of people globally have paid attention to a faint comet most will never see with their own eyes, simply because it might tell us something profound about whether we are alone. That shared attention, that collective wondering, represents humanity at its best. We are curious. We seek knowledge. We ask questions that transcend immediate practical concerns to address deep existential issues. We build instruments and develop theories and coordinate international efforts to study a tiny icy visitor from beyond. We are, fundamentally, a species of explorers and questioners, and that is deeply encouraging. Whatever December reveals, we should be proud of how we have responded to this mystery. Yes, there has been speculation and hype and sometimes irresponsible claims, but there has also been rigorous science, thoughtful analysis, and genuine effort to understand truth. The balance is imperfect but overall positive. We are functioning reasonably well for a species confronting something genuinely novel and potentially paradigm-shifting. So as this narrative concludes, as we reach the end of this exploration of 3I/Atlas and its mysteries, I want to leave you with a sense of hope and excitement rather than anxiety. Whatever happens in December, we will learn something valuable. Whatever the comet proves to be, we will expand our knowledge and understanding. Whatever truth emerges from careful observation, we will be better for knowing it. The universe is not our enemy. It does not deceive or mislead us. It simply exists, with properties and phenomena we can discover through patient investigation. 3I/Atlas is a teacher, offering lessons about chemistry, orbital mechanics, observational technique, or possibly about intelligence beyond Earth. We should approach that teacher with humility, curiosity, and gratitude for the opportunity to learn. The coming weeks will be extraordinary. Stay curious, stay open, stay engaged. Follow the science as it unfolds. Participate in the conversation with thoughtfulness and respect. And remember that you are living through a genuinely historic moment, regardless of how the story ultimately resolves. If you have stayed with me through this entire journey, through all these thousands of words exploring every dimension of the 3I/Atlas mystery, then you are clearly someone who cares deeply about these questions. You are someone who values understanding over easy answers. You are someone willing to sit with uncertainty and complexity rather than demanding premature resolution. You are exactly the kind of person this world needs more of, someone who brings curiosity and critical thinking to important questions. Thank you for your attention. Thank you for your engagement. Thank you for caring about whether a small icy object from beyond our solar system might represent something extraordinary. Your curiosity matters. Your questions matter. Your willingness to wonder matters profoundly. And now, as promised at the beginning, I need you to do something for me. If you have watched all the way to the end of this video, if you have stayed with me through this entire exploration of one of the most intriguing cosmic mysteries of our time, I want you to leave a comment right now. Type the words "December will reveal truth" in the comments below. That way I know you made it all the way through, and it helps the algorithm understand this content is valuable enough to share with more people. Also, make absolutely certain you have hit that like button. I am serious about this. Understanding what is happening with 3I/Atlas could be one of the most important scientific investigations of our lifetime. This content needs to reach as many people as possible. Your like makes that happen. The algorithm responds to engagement signals, and your engagement determines whether this video reaches thousands of people or millions. And of course, subscribe to this channel and turn on notifications. When December arrives and 3I/Atlas reemerges from behind the sun, when the observations begin and data starts flowing in, when we finally get answers to the questions that have consumed so much speculation, I will be here covering every development. You do not want to miss those updates. You want to be part of the community following this story to its conclusion. There is another video appearing on your screen right now that you should watch next. It explores related mysteries about interstellar objects and what they reveal about our galaxy. The story does not end with 3I/Atlas. It is just beginning. We are entering an era where interstellar visitors become regular occurrences rather than rare surprises, and understanding what that means for our place in the cosmos will occupy us for decades to come. Thank you for being here. Thank you for caring. Thank you for wondering. The countdown continues, and soon, very soon, we will have our answers. December will reveal whether we face the universe alone or whether we share it with intelligences who watch us from beyond. Either answer will be profound. Either outcome will change us. Until December, look up at the night sky and remember that behind our sun, hidden from view, something from beyond our solar system races around our star at tremendous speed, possibly executing maneuvers we cannot observe, possibly just being a comet doing comet things. The ambiguity is maddening and beautiful. The uncertainty is uncomfortable and precious. And the resolution, when it comes, will be historic. The cosmos has our attention. The question has been asked. And soon the universe will answer. We wait with instruments ready, minds open, and hearts full of wonder for that answer, whatever it proves to be. This is humanity's moment. This is our test. This is when we prove ourselves ready for cosmic truth. The countdown to December continues. The worst outcome imaginable? Perhaps not knowing was never the worst outcome. Perhaps the worst outcome would be discovering truth and refusing to accept it because it challenges our comfortable assumptions. Perhaps the worst outcome would be living in a universe full of wonders and remaining too afraid or too closed-minded to acknowledge them. We are better than that worst outcome. We are curious, brave, and ready. And when December comes, when 3I/Atlas reemerges and shows us what it truly is, we will face that truth together with courage and wonder. The countdown is almost over. Truth approaches, and humanity stands ready. Comment December will reveal truth. If you made it to the end, hit that like button. Subscribe for updates. Watch the next video. And prepare yourself for what might be the most important December in human history. This is the moment. This is the mystery. This is 3I/Atlas, and soon, very soon, we will know what it really means.